Hello, everyone. I'm Abraham Martin. I work for the University of Cambridge, as you may have guessed from the huge logo in the screen. I was thinking about making a little introduction, and I thought everyone knows what the University of Cambridge is, so I think I have little to say about that. And I thought I can show you some pretty pictures so you can invite me where I live and this pretty place and where I work. This nice architecture, these nice rivers where you can punt with your friends during summer. Well, the 2 days of summers we have a year. The classic math bridge, and you, as you may know, we have a lot of clever people there, some Nobel Prizes, people that usually walk around the city dressed like this, which are guns. It seems weird, but you really look at, when you go there, you really see these people walking around, academics. This seems pretty classic, pretty old, but we also have pretty nice new buildings, like this one, which is the new university data center, which is one of the top data centers in the UK. It's pretty big, it's green, we have a lot of innovation inside it. We even have a HPC service, which has, in 2003, was the second most green computer in the top 500. So it's not just classic building and architecture, we also have some cool things. This is the computer lab where I used to work. I did my relationship with the university started with the computer lab while I was doing my PhD, and then I worked there as a postdoc. This building is called William Gates Building because Bill Gates paid for the half of the building. And I work on this building now, which is the University Computing Service, where we provide IT services for the rest of the university. Both buildings share a common history. And they used to be the mathematical laboratory where this machine, Brownie points, if you know what it is, it's the exact computer, one of the first computers in the world based on the von Neumann architecture, was built there. We still have some pieces in the computer lab as a museum. But also other things were built there, and in the part that I'm working now, which is the University Computing Service, like Exim, which you probably know about because still 50% of mail servers use it. So we have pretty cool people working there. I'm not of any of them, but we have some pretty cool people that also work in a lot of open source projects. So what I want to explain you today is one service that was proposed a lot of years ago, which is the Managed Web Service, and was born to solve a problem. We have a lot of researchers in the university, as you may know, and a lot of them usually hold a conference, they do research, they want to do some simple website with some statistics, show results from the research, or either do questionnaires, etc., etc. So they end up using their own web servers under the desk. It was a cheap computer. It was running under the desk. It was not maintained, usually, because the academics usually use that computer for the conference, and then they left this computer under the desk. The software was not updated, and then we get security problems. We get servers hacked, etc., etc., you know. So the proposal that the IT services and the university did for solving that problem was centralizing these web services. So the solution was to provide a service where you don't have to worry about maintaining the OS or the software. You only have to worry about maintaining the web application. So we maintain the OS. We give basic web hosting capabilities like external services does. You don't have to worry about backups, and you have some dedicated resources to your web app. So that's very, very old. And when I say old, it's like 15 years ago. The first version of the Managed Web Service was using a Solaris 7. running in a Solaris machine. So you can see that it was using a very old version of Apache, PHP, MySQL, and it was using a truth system to maintain the separation between these different web pages. The second version that came sooner than the other one provided a new software like Solaris 10, Apache 2, more new software, and I started to use Solaris Zones, which Solaris Zones is a kind of a virtualization inside a Solaris machine. It's kind of a container. So we were using containers before it was cool, but it's still pretty old. It also had like more enhanced features like database-driven scripts, so you could doing scripts based on some information in the database, so it's centralized, it's better to manage, some NIS and NFS server, very classic, ZFS file system, so it provides also snapshots, which is good, and the users were able to create vhost, aliases, etc. But the problem was everything is manual, so the users have to send us an email saying, I want this, and then we make the changes, we execute the scripts make the changes, but everything is manual, so we need a lot of human intervention. So when it started to grow, we currently now have more than 200 users and more than 400 websites. It started to become a little bit difficult to manage because it requires a lot of time. So before we ended up making a new version of the managed web service, another solution was in parallel, which is the Falcon service, which is Plone-based. You only get a Plone instance. You don't get access to a server or anything. It's just a CMS as a service. And we also have like 200 websites there. So if you go to any university website, you probably will end up in either a Falcon service or a managed web service. So, for example, one of the most visited websites inside this service is the Stephen Hawking's website. So we decided to make from scratch a new service, so restart what we have done, because we don't have more Solaris machines. Solaris machines are routing, and they're pretty old. We don't have a replacement for that. So, and we also thought, let's do more automation. We can do more automation, so it requires less time from us. So we decided to go to the classic dedicated VMs, but still maintain the same things that was proposed by the previous ones, like no root access for users, and everything is maintained by us. And when I say by us, I mean by Ansible, because we don't touch anything, but we will see that later. And so to end up these emails that comes to our inbox saying, can you please install this package? Can you please install this? We created a web panel using Django where we delegate some power to the users, so the users can do things without having root access or anything. So architecture is basically a Debian 8 machine. We install the basic packages that we have been installing up to now, like the Apache, MySQL, PHP, which is the most common features demand. But we also support other mods available, Apache available, like ModWhiskey if you want to install Python or Django, etc. We have also a list of system packages that you can install and that are pre-approved, so you don't end up with a machine with a lot of packages that you don't need or that are strange to need. And we give them all the power to do authorization to the sites, create vhost, apply for domain names, install TLS certificates in the machines, do the backups from them, password resets, power management, etc., etc. So we give them the power to do a lot of things that we were doing before. So they have a panel. Don't blame me for the design. It's an in-house design. If you visit any Cambridge website, you will see that all of them look exactly the same. So it's just a panel with some options to manage your site. So when you create a site, you get this web panel based on Django. You have some options to create vhost, ask for domain names, etc. And you get an extra VM, which is a test server, so you can clone your production server to the test server. You can test things there without having to compromise your production server. So that's good, especially for people that have Drupal installed in the managed web servers. When they Drupal, really bad things happen. So it's better that you can test it before, and if it goes right, you clone it back to the production server. So architecture looks like that. We will go one by one to see how we build it. Be aware that this is not a talk about OpenStack, neither about Docker, so don't expect any of that. But we use most of them are Python technologies, and we did that project in a few months, where it's still not finished. We are still working on it, but most of it, we have done it by using 1.2, 1.3 FTEs. So it's not much people, so the amount of resources that you require for doing it, although it seems like a huge service, it's not that big. So we have here the VM architecture. Here, the VM is separated, the VM service is separated from the rest of the stack. So we start describing the VM architecture. The VM architecture is just a VMware solution. You may know these VMware solutions. It's just a ESXi servers, and you can manage these XCI servers using vSphere control panel and some APIs. And we have external backup server where we do the backups, but it's not replicated. So if something happens, then we rebuild the VM and recover the things from the backup server. So the flow is easy. A user enters to the Django web panel, authenticates, so we know who he is, and then he asks for a new managed web server. A host name and an IP 6 and 4 are allocated to this site. The VM API creates a new VM. The VM API installs the OS, and when the OS is ready, Ansible is executed, and Ansible is the one that configures the whole machine. So we are using Ansible as a configuration management, and it does everything we need. For those that doesn't know Ansible, it's just a bunch of things together. They are easy to script, so it's very easy to understand what they are doing. And they separate into folders, which is really good, and you can find the file that you are looking for, and there is separation of things in the different files that you can see. So it's pretty good to use. It also has inventory, so you can define all your servers based on dynamically or static, so you can have a file with all your servers, or you can inject the output from another API as a list of servers you have, or even the database, etc. So it's pretty nice. It works really well. And it's based on playbooks. Playbooks is just a bunch of roles linked to a bunch of targets. So you have a roles, and definition of role is things you want to install in this role, in these machines that have this role, and then you have targets, and then you say this target, these machines, I want to install this role, for example, a web server. Web server can be a role, and the web server role has a lot of tasks that install Apache, configure Apache, etc., etc. This is an Ansible playbook. As I said before, you define the host where you want to install things, and then you define the roles that these machines in this list will have. For each role, you have tasks, templates, which are Jinja 2 templates, scripts, handles, and variables. You can have also global variables or variables entering into the script. And this is how a role looks like. It's just a bunch of tasks inside the role. You can see that here we're installing packages. It's a YAML file, as you can see. And it's pretty easy to understand what you are doing. So if you have you're working with more people, it's easy to modify the file, change the configuration, etc. You can see here that the templates can be used with variables, Jinja 2 templates. We use variables there, and therefore we use the same templates for all the configurations, all machines. You also have handlers, which are basically callbacks. When some function in Ansible is executed, then you have a callback later, and you can, for example, if you have updated the Apache configuration or your Django app, you can restart Apache, and the callback is cool. So this is from the VM part. We use this VMware infrastructure. We use the APIs. We launch it. We create the VM. Everything is good. After that, after Ansible configures the machine, and then we can offer the service to the user. So if we start from the top of the stack with the authentication part, we have our own authentication. We use Raven. Raven is our authentication service. So you can see that we have a lot of services interconnected using a lot of APIs. It is based on a WebAuth API. And we have to build a custom Django backend. But this could be substituted by any authentication that you can use. You can use the Django one if you want. You can link with your own enterprise if you want, et cetera, et cetera. So the second layer is authorization. We have like a kind of an LDAP-ish service. It's called Lookup. And then what we have there is just a list of users and a list of groups. We can see these users if they belong to which institutions they belong to, which groups they belong to. So the end user can configure their MWS server based on this list. They can search for another users, authorize them as administrators, authorize by groups, etc. So it's just a basic list. We use that instead of using the Django groups because it's more useful for us because people is using the university to this LDAP service that we have. So they create the groups there, and they are automatically updated if someone leaves, etc., etc. So when the user has authorized the user, another user to enter to the machine or use the service, we need to still to install the user into the machine. So we have another service over there called Jagto, which provides more information about users. It's like a user identity management. So we get from Jagto a unique UID from the user. We need that because if we install the same user in different machines, we still need to identify the files that belong to him or to her in different machines. So they have the same Unix UID, and we use this Unix UID in all the user installs. User is installed using Ansible as well. It's installed in all the VMs where it is authorized. And we have periodic refreshes to refresh the lookup groups we have authorized. So if the groups change, people different change. And we allow people to upload their own SSH keys. And the SSH keys is also installed in the user configuration. So they can enter either using their password, which is checked with this LDAP server, or either the SSH that they have installed in the panel. So once they can access to the Django panel and they have the user installed in the VM, they can already access the machine. Everything is configured for them, so they can start using it. For previously, we had also another communication with the IP register API, which is on the bottom there. And this allows us, this is another external service. So as you can see, we have the main service, and then we have a lot of other services that we communicate with, which provides the university a registration for Kamacac domains. So if you want to register a new Kamacac domain, for example, importantstudies.kamacac, you can launch an API. We launch an API request using the same Django panel. Django panel sends the request, and then we get the domain name alias for that site. So everything is configured automatically. The user doesn't have to worry about the process, the internal processes. This API tells us if the user is authorized for that domain name, or if this domain name is already in use, etc. And the same API also provides us from IP addresses. We have to pre-allocate some IP addresses together with the host name. So when the user requests a new site, he can access directly using the domain name without having to wait for a DNS refresh. So what we do is just pre-allocate some addresses And then when the user gets their site, they can access freely using the host name without waiting for a DNS update. We use 2 IP addresses. We have one host name as well as a host address. So the communications for the host, and another for the service. So if we want to move the service to another machine, we can do it without having to modify the host name or the host of the machine. So we can separate what is the service and what is the host, and we can move the service IP. And you will see this is useful later. Additionally, we have SSHFP records and DNSSEC. Anyone knows what SSHFP record stands for? No one. Good. This is to forget about that. I'm sure pretty much you all have seen this screen like that. And what it does is you can upload an SSHFP record into the DNS with your public host key, and then and if you have DNSSEC activated, you don't have to check the host fingerprint manually, because the DNS server does it for you. It gives you, the DNSSEC gives you the fingerprint, and then when you connect, you check that this fingerprint is the one that is in the DNS server, which is secure communicating with you, and then you don't have to check manually if the fingerprint or the machine you are connecting is the one that it's claiming to be. So that's pretty useful. As I said, we have a lot of services in the same architecture. We have an inventory there, which is using another API. It's based on a JSON API on pull, consume. So we give to this service called BES the data of all our services, so we can use it as an external database as well. When we know where all VMs are, we know where they are located, the IP address they have, et cetera, so it can be used even as an inventory for Ansible, or it can be used for other purposes. So as you saw, we have a lot of APIs, different ways of accessing APIs. We use SSH APIs, REST, non-REST, HTTPS, using JSON, non-JSON. But we have to deal with a lot of them in an async way, because we don't want Django, the main thread of Django, be stopped by that. So what we do is executing as a background processes using either cron jobs, which is the easy way if you don't need the API executed just after the user has launched the petition, or if you want the execution schedule, you can use Celery and Redis, which is what we use. Celery is pretty good for us because it works pretty well with Django. It's very easy to configure. You just have to add on the top of the function. You just have to declare that it's a shared task. You can use different templates like this task with failure. You can define the red tree, the number of red trees. You define the template, so you can define if it fails to log something or send you an email, etc., etc. So it's pretty easy to configure, and it works pretty well. And you can also execute cron jobs from the same Celery. It's called Celery Beat. It's a bit different, but the jobs are you just configure it as it was a cron job. So it's pretty useful for us. It works well, and this architecture, this Celery, these APIs and these services are supporting all of this, all Ansible driven. So the changes are done in Django. Django stores these changes in the database, and then Ansible is executed, takes these changes from the database, and then it executes these changes on the VMs. So we had this service. We went to the community in the university. We made a workshop, and we said, we have this for you. We thought that you will like it. And they said, we will like it, but what about if the service fails? And then we thought, well, we have a backup. You can recover for the backup. It won't take too much. We create the VM, etc. And then they said, but I need an SLA if I want to switch to you. But we didn't have an SLA because we had a backup. We have a plan, but we didn't have we didn't thought about what happens if 300 VMs failed on the same time, which requires a lot of time to recreate and a lot of time to take from backups. So some of the people were saying, we are thinking to change into MWS3, but only if you provide high availability. So lucky for us, we designed the application so it can cope with different VM architectures, which is good because you don't have to worry about the VM architecture that the architecture that you are using, because you are creating the VM using an API, which may be this one that we are providing, or it could be an Amazon EC2 server. And then we execute everything through Ansible. Ansible only needs an SSH connection, so it's pretty easy. So we just need to replace this component, which is the VM architecture. So we thought, okay, let's update VMware with high availability. And then we saw that we need replicated vSphere, replicated the storage, which we didn't have, and replicated storage for a lot of servers is very expensive to maintain because you need to huge file storage that is shared between all the VMs. So we had a lot of things pending from this architecture, so we thought that's pretty risky for the low time we have. Better take another architecture because it's still it's also expensive to acquire all the hardware and software that we need. Etc. So we decided, okay, we don't want to maintain a huge shared file system. So what we do is replicate each one of the VMs file system to another one. So we thought we can use the VMware, still use the VMware infrastructure. We add a pacemaker chorusing, which is basically a cluster that checks that all the VMs are in contact with each other and then can change the service network configuration. This is why it's useful to have service network configuration to any of these two production VMs. So we have a replicated VM. The second one, the second column, is just a VM that is waiting in something fails to be changed and I start acting as the active VM of the cluster. And then we replicated the storage individually for each one of the VMs using the RBD, which is basically a driver that sends all the writes of a machine into the other VM. So the storage is replicated to the second one, and the pacemaker takes care that if some of the components fail, the switchover is made automatically, so we don't have to worry about it. But then we thought, this is maintaining a lot of clusters. We may end up with one cluster for each one of the VMs that we're going to have, because for each one of the VMs we will have to have a pacemaker cluster, and this is very expensive to maintain, and it may fail. If we need to execute Ansible, we need to execute Ansible in both sides, in the two VMs, so they are synchronized. So that's a lot of work, and it's going to break quite easily. So we thought, okay, let's start from scratch. We moved away from VMware, and we decided to use Xen. Xen can be configured very similarly as the VMware. So you can see there are two Xen servers there. They are also executed pacemaker and chorusing, but the difference is we don't do clustering for each one of the VMs. We do clustering for each one of the Xen servers. The Xen servers have a lot of VMs inside. So if something happens with one of the servers, the whole server and all the VMs that are inside one of the Xen servers that you can see on the top, all the Xen VMs that have a Xen server, are automatically migrated, live migration, to the second one. And you don't notice anything. Even the sockets are kept open. You don't notice that the switchover has happened. With the VMware solutions, you will have to wait until we restart the VM, for example, and that kind of stuff. With Xen, you don't notice anything. You just don't see that nothing has happened. So, but inside, you have changed your VM from one Xen server to the other, but it's completely transparent to you. So for doing that, it's a bit more complicated because this is the file system that we had to use. This is a very complex file system where you have all the disks. These disks are tied together in a physical volume, and then you have the left one is the DOM0, which is basically the operating system that is running in the Xen server, and then each one of these are each one of the individual Xen hosts. So you have all the storage replicated to the other Zen server, which provide this live migration. So we had a happy transition. It's working well now. But the architecture is the same, because we designed the architecture so we could change the VM provider, but just changing the API. The API is a middle API, so we only had to write an API for the Zen server, and then execute everything was exactly the same. So we are happy with that. Seems people may be happy with that as well. And we changed it from the VMware solution to the Zen solution, which is 3 node clusters. The node clusters are in different locations. We can do live migration, so the users don't notice anything. It's still using Ansible. And we also use Ansible to deploy more clusters. So this is an example of the Zen server clusters. We can deploy many of them. It is easy to deploy because it's Ansible. So if we want to create more Zen server clusters, it's just as easy as get the machine, the physical machine, start it, and launch Ansible. So it's pretty easy. Let's talk 1 minute about security, because we like security. Well, I am not an expert in security. We like to enforce security to our users, so we then end up with problems. We decided to not use root passwords when we create the Zen host, so the people, we don't have to manage root password, which is difficult to secure a lot of root passwords in a database. We don't want to manage that way, so we only use keys. We connect to the machines using keys, Ansible connect to the machines using keys, etc. We have a separation of privilege. For example, we need to pre-generate the host keys of the Zen host. The host needs to be generated previously because we need to upload the SSHFP records before even the machine is created. So we need to have a pool of host keys that we can use in the future and we can install in the machines. And we use user service, which provides a useful interface. So users can execute commands from root users or other more privileged users based on some filtering and some templating. And we also provide a TLS certificate service. This is an additional one, because we want to follow one of the new initiatives from the FFF and the Mozilla and AKMA, which is HTTPS everywhere, or Let's Encrypt. Let's Encrypt is an open source CA, which provides you with a free certificate for your web page. HTTPS everywhere is EFF trying to force everyone to have HTTPS web servers. And even the HTTP2 specification doesn't include to enforce HTTPS, but a lot of people are saying, well, when we move to HTTP2, everyone is going to be HTTPS. That's not really true, but because the specification doesn't say it, but all the implementations from Microsoft in Internet Explorer, and Mozilla, and Google in Chrome only implemented HTTP2 if it uses HTTPS. So we like it to test our servers. I encourage you to do the same. If you enter to the SSL Labs, you can get a qualification how secure is your web server, which is pretty good because it gives you some hints of if you have any open back, all the specification, all the version of OpenSSL, etc., etc. And apart from security, changing topics, we use also some metrics and logging systems. So we can have users, we can give users some information about how their host works. For example, we use a metrics service, which is basically a statsd and collectd in each one of the machines installed, also using Ansible. We have a cluster of message brokers that get this information from all the hosts. And then we have a cluster of Carbon Graphite, which stores this information gathered from all the machines. So the user can see these graphs in their panel, the web panel, and they can see how the machine is behaving, etc., etc. And we are now trying to implement Logstash, Elasticsearch, and Kibana, which also provides information about the hosting, the web server, and how it behaves. Where do you have the visits? How it behaves during different periods of time, etc. So you can have a lot of logs gathered by Logstash stored in Elasticsearch and then showed in a Kibana. So that's pretty much all I wanted to talk about. I hope you like it. Thank you.
Thank you, Abraham. And we have a few minutes for questions. Any questions? Yes?
Why did you choose Xen instead of KVM, for instance? I mean, what made you choose one thing and not the other?
This was a long discussion we had between the developers, which is basically three. We didn't have any strong reason to choose one or the other. We saw, doing a little bit of research, that Xen worked a little bit better with DRPD, which is one of the main components we wanted to use, because we wanted to do the replication of storage from one Xen server to the other. So we saw that it was integrated inside the same Xen server, and we decided to go that way. But we could have chosen KVM. It was in the list of products that we had to research and decide.
Hi, thank you for the talk. It was really fun, but to be honest, I didn't really understand the subtleties in the last architecture, because you had several hard drives and that you have several Xen servers that actually overlapped on several drives. So were they virtual servers or?
Yes. So this, the whole picture. So this is the picture of the VM architecture on the top. This is more the view of the file storage. This is a single machine with a RAID of disks. And this is a file storage for a single machine. So you have the physical volume, and then you have the first column is where it used to be DOM. It's called DOM0, which is the operating system that manages all the VMs. When you access to the Xen server, you access to this. It's also a VM, but you access to this, and it has direct access to the hardware instead of the VMs, which have access to the hypervisor. And all the other columns, each one of them, are a Xen host, which are one of these VMs, or DOM-U, as it's called in Xen. And each one of them has the DRBD device, which is basically a virtual block device, which is replicated from here to another DRBD server. So you have each one of these DR devices are inside this list of virtual block devices, and they are replicated through the network in real time when they are written or read, only written because it's a sync, to the secondary Xen server. So it's done automatically through the network when it's executed, but the difference is each one of them has a DR device.
Okay, thank you.
Okay, we have maybe 1 minute if anyone has a really quick question. No? Okay, please join me in thanking Abraham once again.